Welcome everyone to the AI Research Roundup. I'm your host Alex, and this is where we dive into the latest developments in AI research. Today we're looking at a paper titled Affordable AI Assistance with Knowledge Graph of Thoughts. So the big idea here is that while large language models are making AI assistants really capable, current ones can be very expensive to run and don't always succeed on complex tasks. This paper introduces an approach called Knowledge Graph of Thoughts, or KGoT, which combines LLM reasoning with dynamic knowledge graphs, allowing even lower-cost models to perform much better and way more affordably. Right, so this first figure gives a great example of how KGoT works. You start with a complicated task, a question from that GAIA benchmark they mentioned. The system builds a basic knowledge graph from it. Then, crucially, it uses tools like web search or text inspectors, maybe even a YouTube transcriber as shown, to find missing pieces and add them to the graph. You can see the graph getting richer over time. Finally, it extracts the answer directly from that structured knowledge. It really visualizes that iterative enhancement process. Okay, so building on that iterative process we saw, this next figure really breaks down the KGoT system architecture itself. We can see the main modules, the graph store, where the knowledge graph actually lives. The integrated tools block showing a wider range like Python code tools and text inspectors, and critically a controller orchestrating the whole thing. What's really detailed here is how the controller uses two LLMs, one focusing on the graph state and another on calling those tools. It also shows different backend options for the graph, like Neo4j or Network X, and that core decision loop, where the system decides whether to enhance the graph more or try to solve. Okay, so now we get to the results. This figure really shows the payoff of that architecture we just discussed. It's comparing different KGoT versions against baselines like Zero Shot and Hugging Face agents, both in terms of how many tasks they solve. Higher bars are better on the left, and the average cost, where lower bars are better on the right. You can see the KGoT variants using the cheaper GPT-4o mini model consistently solve more tasks than the standard Hugging Face agent with that same mini model. And importantly, look at the cost comparison on the right. KGoT is way more affordable than using the full GPT-4o. Right, so building on those overall performance numbers, this figure really hammers home the value of the knowledge graph itself. It breaks down results using different graph backends like Neo4j and Network X, and different ways to get the answer out, like query or direct retrieval. But the crucial comparison is on the far right, the no-KG baseline. You can clearly see that all the KGoT approaches solve significantly more tasks, especially the KGoT method. It really shows that structuring the knowledge is key. Okay, so we've seen the benefits of KGoT with specific models and the importance of the graph itself. Now, this figure broadens the picture. It shows how KGoT performs when paired with a whole range of different language models, like Qwen and DeepSeek, not just the GPT variants we saw earlier. The top chart compares KGoT against the Hugging Face agent's baseline and Zero Shot again, but for each of these different models. And the bottom chart really highlights the lift, showing how many more tasks KGoT solves compared to the baseline for each model. It demonstrates that the KGoT advantage isn't specific to one model. It generally helps across the board. So yeah, it's pretty clear KGoT offers a general boost regardless of the specific language model you plug in. Really, the big takeaways here are that structuring agent interactions with a knowledge graph, well, it significantly improves task success rates and dramatically cuts down on the cost. This is really important work because it helps make powerful AI assistants much more accessible. That's all for this episode of the AI Research Roundup. Thanks for listening. I'm your host, Alex.